the data analysis. In this lecture, we will be discussing about the fundamentals of the data analysis, and these fundamentals basically involve the very basics of these statistics, because statistical data analysis is the topic that is the objective of this course. So let's start with it. Data analysis basically mean methods to understand your data so that useful information can be extracted from it. Now, this is a very, very important point. Analysis of the data just does not mean this thing, just doing the analysis as a mathematical working, and then after the mathematical answer, no interpretations about it. The analysis is considered to be concluded accurately and properly when the interpretations from the results have also been obtained and they make some sense. Otherwise, the analysis is of no use. So, basically, data analysis involves the data summarization so that we can start understanding the data properly, making the plots or graphs of the data modeling so that predictions and classifications can be made. Basically, the data analysis comes under the domain of data science, in which we study about statistics and the machine learning. In this series of videos, we will be covering the statistics portion and the probability portion first, and then later on, we will move to the machine learning or the artificial intelligence part. But before starting the data analysis, we should remember this thing, that to what entity we call a data. Just putting it in this way, that data is a set of values does not make it complete. We should remember this thing, that all these analysis things like summarization, plots and graphs, and prediction and classification are done on those experiments which are probabilistic or statistical in nature. What do we mean by an experiment which is probabilistic or statistical in nature? By statistical nature experiments, we mean this thing, that those experiments about whom we are not sure that what the output will be. There could be different outputs at different instances of time. And this makes the problem, because when the output is not fixed, and if somebody asks you that what is the output, then definitely we cannot answer the question. So what we do is this: we start doing our experiments, start collecting the outputs in the form of the data, and gather them in the form of the data set, and then we do the analysis of it, right? So if, in order to make this thing understandable, let me take help of a block diagram. Now suppose this is some system, right? And to this system we apply some input or a set of inputs. There could be one input, there could be two inputs, or there could be different inputs, right? So this is our input. Let me name it as the inputs. And because of these inputs, let me put another arrow just to indicate that there could be more than one inputs. And because of these inputs, sorry, the system processes them. So this is our system. This is our system. System processes them, or you can also take it in this way, that the experimentation is being done, And because of this experiment, or after the processing of the system, we obtain an output. Now this is the output. Now there could be two things. Either it would be the system would be working in this way, that after applying the inputs, we got the output, and every time we apply the inputs, we get the same output. If this happens so, then life is very easy. Because if anybody asks me that what is the output, then I would be sure to answer the question with full confidence that the output is this. Like for example, if I say that I indicate the output with some variable x, let's say, and suppose that numerically the output is 2, then whenever I apply the input, I get the same output. And if anybody asks me that what is your output, then I would say that the output is 2. I would have no doubt about it. Important thing is this: no doubt, full certainty, no uncertainty, right? Such type of systems or experiments are basically called the deterministic systems. But suppose that what happens is this, that at one instant of time when I apply the inputs, I get the output 2. At second instant of time, I get a different output, let's say 2.1. At another instant, I get a different output, let's say 1.8. And then again, I get something like 2.2, then 2. Now, if anybody asks me that what is the output of your system, then would I be able to answer this question? No, because it is giving me different outputs at different instances of time. This is where the problem starts, that we do not know how to give the output of the system. And when this happens, we called this system a non-deterministic or random system, because it is giving me outputs which are random in nature. This set of outputs is what we call a random variable. So this set of outputs is what we call a random variable. So this x, so over here, this x is what we call a random variable. So this is the random variable, and each and every single output of this random variable, or we can say the values of this random variable, are called events. So 2 is an event, 2.1 is an event, 1.8 is an event, right? And this random variable is also what we called, or what we can understand it as a data set. We can also name it as the data set. Our objective in statistics is to be able to analyze such scenarios, such data sets, such random variables. In the probability part, we had gone through this definition. So it was just a recall of the things, so that we should remember that how the two are related, the probability and the random variable analysis or the data analysis. Because data analysis is only performed on probabilistic systems or non-deterministic random systems. So if we have a good understanding that what are the probabilistic systems, what are the probabilities, how the probabilities are calculated, then definitely it would be much easier for us to understand the data analysis. Like for example, let's recall this thing that these are the events which are coming. Every event has a certain probability of occurrence. And if we are able to get out this probability, to find this probability, then definitely we would be using those probabilities to analyze this, the non-deterministic or the random system. And once we are able to analyze this system, then this means okay, we are able to understand our system. We are able to understand how this system works. We are able to understand the characteristics of the system. We are able to understand the behavior of our system. And once this is done, then it means we can do the predictions that what would be, for example, the output in some future state of time. So this is the whole purpose of the statistics. Now, the way the system works could be a very simple type of thing. I mean, it could be a very simple system, or it could be a complex scenario as well. And in this course, we would try to understand the analysis of some simple random systems and the analysis of some complex random systems as well. So that's how these things work. I hope this introduction is understandable to everybody. So let's proceed further. Now, in the analysis of the random systems, we basically start with the summarization of our data set. Now, this is very important to understand. Remember this thing that fundamentals are always very important. If the fundamentals are good, then you would be able to understand everything, more complex things as well. Like for example, if you see a very huge tree in a garden, a big coconut tree, then remember this thing that in order to get that big coconut tree, it is required to have a very good seed that could be sown in the soil. If the seed was not good, then the tree would not come out. And seed is the fundamental thing. So fundamentals are always very important. Okay. So the summarization of the data can be made either as ungrouped data statistics or group data statistics. What do we mean by it? By ungrouped data statistics, it is meant that either the data is in this way or we are deliberately taking it in this way that each and every single value in the data set has an equal chance of occurring at the output. They have equal weights. And when this happens, then definitely the frequency of each value in the data set would also be equal to 1. The opposite happens in the group data statistics. And what happens in group data statistics? By group data statistics, we mean that the probabilities are different, and so the frequencies are greater than 1, and so the analysis would be a little different as compared to the ungrouped. Let's take a simple example to understand this idea. Suppose I have a data set or a random variable named as x, and there are certain values in it like 1, 2, 3, 4, 5, 6, 8, 10, 11. So in this data set, the total number of values, if it is indicated by capital N, or the data set size is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 values in it. Okay. If I ask you that what is the probability of each event or each value in the X to appear on the output, then I think it is a simple answer that probability of each value of X is basically equal to 1 upon 9. And why it is like so? Because firstly, we can see that every value is occurring once. And secondly, we can see that if I am taking it as an ungrouped data statistics, and this means that every value has an equal chance of occurrence, then this can only happen when every value has a probability which is equals to 1 upon capital N. Remember the rule of probabilities that sum of the probabilities of all the mutually exclusive events is always equal to 1. So the sum of their probabilities that are present in the data set, I mean the sum of the values of the probabilities that are present in this data set X would only be equal to 1 when every value has a probability which is 1 upon 9 in this case, right? And we know this thing that probability is the ratio of the total number of favorable cases upon total sample space, or the total number of frequencies of the favorable events upon the total frequency. So this means that every value has a frequency value which is equal to 1. So this means that this data can be summarized as an ungrouped data statistics. But an important concept to understand is this, that it is not necessary that, I mean, it is not a very right way to say this thing, that this data is ungrouped data or this data is grouped data. Because the same data which is being analyzed as an ungrouped data statistics can also be analyzed as group data statistics. And we will see later on. Like for example, if instead of if instead of taking each and every single value separately, suppose the data would have been a very, I mean, the size of the data would have been very huge. Instead of this nine, suppose there were, like for example, many values. Like for example, there were some hundreds of values present over here. Then definitely this does not make any sense, any good sense, that I analyze this data set taking each value separately individually. Rather, what we do in those cases is this, that we take group of values, and these groups are basically called the classes or the intervals. So we divide the data in different groups or in different classes, and then we analyze the data. And if this happens, then definitely the frequencies of the values that are present in groups would be other than the value of 1, greater than 1. And such type of analysis is basically called a group data statistics. Or it may also happen that the data appears in this way, that the frequencies are naturally greater than 1. Like for example, let's say my data set is something like this, that x is 0, comma 0, comma 0, comma 0, comma 0, comma 1, comma 1, comma 1. Then there are 2's, then there are 3's. Let's say this is the data set. Then definitely every value has a frequency which is quite apparent that it is different from 1, or there are different frequencies. Like zeros have frequencies which is 5, 1 has frequencies which is 4, 2 has frequencies which is 4, and 3 has 2. And suppose there was 4 and 4 is a frequency which is 1. So definitely this data can also be analyzed much better, in a much better way, if it is taken as grouped data statistics. So by summarization of the data, we mean that it is upon us that whether we want to analyze the data set as a group data statistics or as an ungrouped data statistics. We will start our discussion of the data analysis firstly with the ungrouped data type, and then with the, ungrouped data statistics type, and then with the grouped data statistics type. In data summarization, after taking it as a group or an ungrouped statistics, we basically find there are some basic statistical parameters that we will be working upon. Like for example, there would be range. We must understand the idea, the concept of the range. Then there are measures of positions, which are basically the positioning statistical parameters. And there are certain specific positioning statistical parameters that we will be working upon. These include quartiles, percentiles, and deciles. Then there are measures of shapes, and in measures of shapes we will be looking at how we find the shape of the distribution. This measures of shape could be done either by tabular method or by graphical method. And then we would be working upon the modeling of the data, and there could be average or the mean value models, there could be linear models, there could be non-linear models. And then we would be working, since remember this thing, that models are used to predict the data, the value of the data set. And when we do the predictions, then predictions does not mean this thing that this is something exact. Predictions, by the nature of the word itself, suggest that it is an approximation. So definitely there will always be errors in the predictions. There is no such prediction with zero errors. So every statistical model that is used to do the predictions have errors in them. But we say that some, like, statistical model is a good model, is a better model when the errors in it are low as compared to the other. So it is while working with developing the statistical model, it is equally important to also understand that how the errors in the models are determined. So we would be working upon errors in the models, which basically include the variances and the standard deviations. And finally, we would be working that how we do the predictions. So how the predictions are made, combining the model value and the error value to give us the idea, the error margin, and how the interpretations in the end are made on the analysis results, so the proper conclusion could be drawn. So that's what we basically study in the analysis.